Oh, you caught me being all proper, but we are back with anatomical analogies. In this discussion, we're going to delve into eicosinoids. So, not as much analogies once again in this episode, but we are just going to spit facts, spit info, spit knowledge, and we're going to keep it all up here and we're going to learn it so that way we can apply it. So, eicosinoids, first off, they're local hormones. So, most hormones, they have their effect far from where they're secreted. So, say a hormone secreted here in the thyroid gland, it travels down and affects another portion of the body. But eicosinoids, on the other hand, they're local hormones. So wherever they're secreted is where they're going to have the effect, and their effects are obviously at the source of secretion, but their effects are promote inflammation, and they also affect clotting. So they can act or function as a procoagulant. So they promote clotting, or an anticoagulant. So procoagulant, anticoagulant, prevents clotting. Procoagulant or coagulant promotes clotting. So eicosinoids not only affect and promote inflammation, they affect the clotting of the blood as well. So say, for example, if you're taking an NSAID, NSAID, like a ibuprofen or something like that, which is an anti-inflammatory, helps reduce inflammation. If you take an eicosinoid, it's going to inhibit or prohibit the anti-inflammatory effects. Since eicosinoids are promote inflammation, it's going to pretty much cancel the effect of an NSAID if you're taking one, and it also will affect the clotting. But just for the example of taking an ibuprofen and NSAID, an anti-inflammatory, if an eicosinoid was mixed with that, or if eicosinoid was secreted for some reason in the body, it would cancel out the anti-inflammatory effects of the NSAID, because eicosinoids do promote inflammation there. So pause the video real quick and look up a image or a picture. Google eicosinoid. They also have a pretty unique structure to them, and we're back. Okay, so hopefully you did Google that and you looked at the big long hydrocarbon chain. So they are nonpolar eicosinoids, and as you just saw in your image on Google, they're a carboxyl with a hydrocarbon chain with 20 carbons attached to it. So it's that carboxyl. It's the specific functional group, and then it has a long hydrocarbon chain with 20 carbons to it. So it looks like the jagged, really long chain attached to the carboxyl. Pretty unique structure to it. So it's easy to identify an eicosinoid when you see it. It's that they look the same pretty much every time. So eicosinoids are that long, straight hydrocarbon chain with 20 carbons, where steroids are that four carbon chains, 3 or 6 sided, one's 5 sided. So that kind of weird jagged structure like that, as you looked up in the video prior. I hope you did pause and look it up. And then the eicosinoids are that long hydrocarbon chain with 20 carbons attached to those to the carboxyl. Pretty unique, pretty identifiable. But look at it a few times, it'll sink into that gray matter in the brain. But we'll see back here soon after a quick break, actually. Quick bathroom break, we'll call it. I was going to say a biological excretion break, but we're just going to call it a bathroom break. See you soon.